Traditional control architectures are great for standard machine operation. Take inputs, make decisions, send outputs. However, most PLCs aren't designed to thrive in Industry 4.0 architectures. They struggle at logging, pulling, and handshaking data with higher level systems. The PLCNext Controller from Phoenix Contact bridges these gaps. It's an IIoT controller designed to access tags in a global data space and then allows you to use those tags in a Linux environment. This controller talks all major industrial protocols and can be programmed just like a traditional PLC, however has a Linux backbone, so it can handle the higher level programming. Any kind of scripting and APIs can be handshake that data with the traditional PLC side of the controller. A great example of how we use this is with AMRs, specifically MiR. When having a fleet of robots servicing multiple production lines, there needs to be communication to a higher level system to determine which robots respond to a material call. Standard PLCs can't communicate directly with warehouse management systems or fleet deployment software. Sometimes, SCADA is the answer. However, SCADA software can be very expensive and may not be an option for every application. The most economical solution is a PLCNext controller. This is hardware-based and a fraction of the cost of SCADA. So when a production line makes a material call, it pulls those Ethernet IP tags from the controller. From there, that controller acts as a gateway and communicates directly with MiR's fleet software via some basic Python scripting. And as an added bonus, we can easily dashboard key metrics like battery life, utilization, and distance traveled. It's pretty slick. Let's take a look at how we set that up. All right, so when we take a look, what we're looking at right now is our RS Logix program, just a basic kind of a demo program. We're going to pretend that this is our machine program, and this is on a demo controller that's not currently in view. And for the sake of today's conversation, we're going to go ahead and pretend this is a production line. And down here we have our bit for our material call. So when our machine runs out of incoming material, we need to communicate to MiR's fleet software or fleet manager to deploy a robot to come bring us more material. That's that bit to start that process. Here we have our PLCNext engineer. This is going to be where we program our PLCNext controller to pull that Rockwell tag. So when I go over here, I make that tag high, you can see that it's changing over on the PLCNext engineer side. So now that I've completed that, the next part of the process is it's communicating with the Linux side. And this is our Python script. This is where we reference the Rockwell tag that we pulled. So when this goes true, and we're monitoring, so when that happens, it sends a material call to the Fleet Manager API. And then below is what we'd write back to the Compact Logix once that move is complete. So now we can even take this a step further, right? We talked about this controller kind of being a gateway. Well, it can also act as some basic dashboarding, right? Since we're already communicating with the fleet software and the PLC, we can get some basic feedback and metrics off that robot. Or off that robot fleet in this case. So here we can get the utilization, right? We can see how often each robot's getting used and how optimizes your fleet. We can see the status, whether it's charging or working, as well as the overall distance traveled. We can even tell how many tasks have been completed, as well as how many failed, as well as the status of, hey, are we waiting on an incoming call from one of the robots? This is just one of the many ways. This was an application that we kind of threw together here just to get you thinking about PLCNext a little bit as a technology. This controller is impressive and has a lot of capabilities. Let us know how we can help on your next project.